So today our topic is vector application and analysis. And here we will use data from Singapore to demonstrate the operations and spatial analysis methods we can use in SuperMap iDesktopX. And so the session are going to be divided in these three parts. First, we will have a quick introduction on the study area of today's demo, and we will explain the case we are focusing on, so that you can have a general understanding of the goals we are going to achieve upon the completion of the demo. And in the second part, we will learn about the data we collected for the case, and most of them have been imported into SuperMap SuperMap data source. So all we need to do is to extract some information hidden in those data set. And so our method to extract this new information is appending attribute tables and conduct some field calculations, so that we can get new information for our case. And after the second part, we will take a 5-minute break, and then before we proceed to our final part. So in the third part, we will design a decision-making workflow, and so that we can achieve our goals of the case by using spatial analysis tools like coring, buffer, and overlay. So now let's first have a look on our study area and our goals of the case. So today our focus is moving further south to Singapore, and Singapore is one of the most popular destinations of travel in the world, and it is featured with multiple culture society, and tropical weather and beautiful city sceneries. It is also famous for its abundant shopping malls and its tasty and cheap food. It's tasty but affordable food from the hawker century. So today our case is going to find some suitable locations to build new hawker centuries. So first, maybe you're curious about what is hawker centuries and why are we going to build some new of them. So as an open air complex of delicious food from varied culture, hawker century plays an important role in local life of Singapore. As from a research, we can learn that about 60% of the local people eat one of their daily meals at hawker century, and also it's a great attraction for the tourists from all over the world to experience the local lifestyle of Singapore and its local cultures, and also they can have wonderful food here at an affordable price. So you can see how crowded it is every day here. And so hawker century works both as an economic boost and life convenience for the local communities, especially for those with relatively low income. So when we are planning new locations for hawker centuries, we should consider how to make it to serve a large number of citizens, and also use them to help those people with relatively low income at the same time. So based on these discussions, here we can break down our goals into, here we can break down the criteria for suitable land for new hawker centuries into 5 small goals. So here first, at a larger scale, our location should fall into planning area with high percentage of low-income household, so that we can help those people to find a new way to make a living. And secondly, at a smaller scale, we would want to place our new Hawker centers in subzones with high population density, so that we can make sure these new Hawker centers can attract enough customers. And then the centers should use the land with proper type of use. That's a key in city planning. And then fourthly, considering the transportation convenience and life convenience, there are also requirements for proximity around your location to metro stations in Singapore and also the local supermarkets. And finally, it is obvious that our new Hawker centers should not be too close to the existing ones. So we will keep these 5 goals in our mind, and then we will achieve them step by step in SuperMap iDesktopX. So now it's time for us to have a look at our data prepared for this case and extract information we need to extract information we need to know according to the 5 little goals. So here, let's first have a look at the data. We have most of the data stored in the UDB data source called Singapore. And here you can have a quick, and here is a simple introduction for each of them. So first, we have the one of detailed land use planning of small pieces of land in this whole country. And then our planning area are divided into land, and then we have planning area that divide the land of Singapore into 55 areas, and each of them has a population around 150,000. And also we have subzones. Subzones are much smaller than our planning area. So we could have a further look into the local communities by looking at the data collected at the scale of subzones. So here the population data set we have is also counted at subzone scale. And also we have some data sets for our points of interest, like the metro stations, supermarkets, and current Hawker centers. And so, as we just discussed before, our criteria for suitable locations, including the consideration on population density and the percentage of low-income household in planning area. However, we don't have these two data directly, but we can extract them from the data set we already have. And so in this part, we're actually focusing on the operation of the attribute fields of vector data sets. And so first, we need to append our population data set, our population data, which is stored in spreadsheet into our vector data. And so that includes 2 spaces. First, we need to import the CSV file into SuperMap iDesktopX, into the data source of SuperMap iDesktopX, and then we are going to append the population data inside it to the vector data of subzone. So now let's switch to the iDesktopX and complete these 2 steps. So here, if you haven't opened up SuperMap iDesktopX, just open it now. And when you are opening it, we can firstly have a look at the data we provided to you. So here, under the data, under the material folder for this session, here's 3 files. The first one is the slides, and then we have a UDBX data source. We can connect it into SuperMap iDesktopX, and then see data sets inside it. And also we have an independent CSV file of the population the population counting on subrows by their binary type. So here we can first open this CSV file and has a quick look at the data set. So here we can see it is counted by subrows, and also it has a name for the planning area it belongs to as well. And here we have the total population and the population lived in HDB house, in HDB apartment, and also some more detailed information rendering. So here, our first step in SuperMap iDesktopX is still connect our data source into the software. So here, select data sources and right click. Here, choose open file data source, and then navigate to our materials 03 and select Singapore. Click open. And now here we can see this. Here are the spatial data we already have. And then we're going to import our CSV file into this data source. So select Singapore and right click on it. Here we will select import data set. And now here on the right left, here is plus button, click on it, and then navigate to materials for today's session. And so we can directly select this CSV file called population by dwelling type and click open. And we can see that there is a slight difference about import CSV file comparing to import Excel file, because CSV file always has a separator, and here the system automatically read it as comma. So this comma is exactly the separator we used for this CSV file, so it can read the data in correctly. And sometimes, if the separator decided by the system is not what actually the data is not what the CSV file actually used, like here, I will change it to another one. So here we can see if the separator you specified is not correct, then the software cannot read the data in CSV file in the correct format. So then in this case, we need to check what is exactly the separator is and change it to that one, like here. And so also don't forget to check read the first row as the field info. And now we're okay to click on import. And here we have imported the CSV file, the data in this CSV file as a table. We can double click on it. And here we can see we have all the information just as how we just opened it. And here we can find that for the field of subrow and planning area. So these are the fields of text information. And here, then for the population, for those fields for population data, they should be numbers, and we can check in the property of this table data set to see if it's in the correct, if they use the correct type of data. So here, select population by dwelling type and right click, and then select property. And on the right, we can see this is the property for this table. And here we will switch to the tab of attributes. And under it, we can see for all the fields, the type assigned to them. We can change the size of this interface, and we can see that all the types assigned to these fields are wide characters, which is a type we can use for text data. It's okay for subzone and planning area name, but for our population data, we want to read them as numbers, not text. So here we can change the type of these fields. Just click on the type of total population, and here we can see all the choices we can use. And here we would choose double, and it's the same for all the other fields below it. And here, as we have made some changes on the field type, there's similar nothing happened in the table because we only changed them in this property window here, but we haven't clicked apply. Once we have made our mind that this is all the changes we want to do for this for those field settings, then we can click apply. And once we click apply, you can see that all this data in those fields are read as numbers. And we need to set them to numbers because later we will use those fields for calculation, and we can only calculate numbers. We can't calculate text, right? And so then our next step is we want to combine or attach or append those population data in this table into the attribute table of our subzone data, here MP subzone. We can first select this data set and right click on it, then choose browse its attributes. And here we can see now in the attributes of this data set, we only have the subzone names and also the planning area it belongs to, but we don't have population here. But however, comparing the attribute table of subzone and the table of the population data, we can see that both of them has a field of subzone names. And here, subzone names are unique, while we have some same records in the planning in the name of planning area. So there is a one-by-one connection between the subzone name in the population table and subnode in the attribute table of this subzone vector data set. So here we can use these two fields to combine the data to append data in this population table to the attribute table of the subzone vector file. So to do that, the tool we're going to use is under the data tab. Click on data tab, and then under data processing, here we can find the tool called append columns. in the session of last week, we use the tool called append rows, but this week we will learn how to use append columns. That is to add more attribute fields to our current data set. And here we can first we need to set our target data set, and that's where we want to add more attribute fields. And so here our target data set should be this subzone data set, MP subzone, and the connection field, that is a field I just showed you, like the field that is the common field or the connection field between these two tables. And so here we need to specify it as the field of subzone name. And then it's the same for our source data set. First, we need to set the source data set to be this population by dwindling type. Here, when we are changing when we are changing the type of the attribute here, when we change the type of the attribute field, the system, the software automatically generated a backup data set for us in case we did some wrong choice and we want data back. And so here we will choose our new data set that is called population by dwelling type. And then the connection field, we should also choose to be subzone. Here we can say, although the name for these two connection fields are different, but the data type for them are same. Both of them are the white characters, and also they have same records between them. So we can use these two of them as the connection fields. And then we can choose what are the fields exactly we want to connect, we want to append to our vector attribute data. So we can select all of them, but actually we don't need that much. So we can unselect all of them first, and then just choose what we need. So the first one we need should be the total population of each of the subzone, and then is the population lived in HDB labs in each of the subzone. So these are the two fields we want to add to MP subzone. And so that's all the settings we need to set. Once you have set it, click on this run button. So here's a warning that we have already opened it, and the tool we are using have to do some changes to it. So so the software has to close it first. So just click OK. And now we can see that the module is successfully running the task. And so again, now we can open the attribute fields, the attributes for this subzone data set. And now we can see that there are two fields, total pop and HDB, has been successfully appended to its attributes. So that's all we need to do on how to import and then append useful data in that field, append useful data in this table to our spatial vector data set. And here we can have a quick review on what we have just done. So first, import CSV file and use the correct separator for it. And then make sure the field time is correct. those field types are correct. If they're not correct, change them, and then remember to click apply. And lastly is about how to append attributes to our vector data set. So here first we need to find. So here the first thing we need to remember that to do that we must have a pair of connection fields between our source and target data sets. And so here I have highlighted the connect fields for these two data sets. And we can see here are two requirements for these connection fields. The first one is they should have the same field type. And the second one is they should have some same values in the records. They don't have to have the values in these two fields don't have to be all the same, but there must be at least one same value in that record. And then the tools we're going to use for attribute append is append columns under data tab in the group of data processing, and choose the correct connection fields. And then we can successfully add the fields we need to our vector data set. And so then our next step is to calculate our subzone population density. And to do that, and to calculate the population density, first, we need to know the exact area of each of the subzone. So we need to create a new field to contain the area values for each of the subzone. And then we need to create another new field to store the population density we have calculated. So here we have to create two new fields first, and then use them calculate the area and the population density. So now let's move back to our software. And here under Data Manager, select empty subzone. And on the right, we can see in this window, on the right, we can see in this properties window. Now we can see here are the attributes information for subzone data set. And now we have 10 fields in total, and we can add 2 more of them. Here, click this plus button. Now we have added field 11 and field 12. And then we can set their names first. And so just double click here. Then you can change the name of this field. And so here we will name it as area. And for the other one, we will name it as population density. Here, for simplify, we will type in pop density. And then just similar to how we change the field types, after we have created new fields and set their names and their types, you need to remember to click apply so that all the changes are actually ended to your data set. And so here, click on apply. Now we have 2 new empty fields here. And so the next step first is to calculate the area for each of the subzone. Then we can use that to calculate our population density. So to calculate the area for each of the subzone, here we have a tool. So we can see now we're under the tab of attributes, right? So under attributes, here we have a group called edit. And under it, we can see the second The second tool is called calculate geometry attributes. That's one we're going to use to calculate the area for each of the features. So click on it. And so here we can see the data sets we're focusing on is subdome, so there's no problem with it. And then for the select model, that is to say how we want to save our calculation result. If you want to calculate, if we use the default as calculate geometry attributes, it will create a new field it will automatically create a new field to store as a record for feature areas. But now, as we already have created an area in a field called area, so here we can switch to update geometry attribute. So the calculated result will be stored in the field we already have. So here under the update field, we will select area. And then for the geometry property, that is to say which kind of geometry we're going to calculate it. And we can see that we have a lot of choice here. We can calculate the central point coordinates for X or Y, and also the partial coordinates or the number of nodes. And so here, here we will choose to calculate geometry precise area. And then we can set its unit. Here we will use square kilometers. And that's all the settings we need to do. If you have the settings the same as mine, then you can click run. And also, because we have already opened this, the attribute, and now we want to do some changes, so we have to close it first. And now it's complete. Let's reopen the attribute for subdome. Here we can see for the field of area, it's no longer empty. We can see the calculation result here. And then it's time to calculate our population density. So it's easy to calculate it. We only need to divide our total population by the area of each of the subdome. Then the result should be its population density per square kilometer. So to do that, still we can go to the tab of attributes, and under it, in the group of edit, here, the tool we're going to use is update field. Click on it, and it can automatically read the field we want to update is population density. If you want to store it in other fields, here you can choose the one you want. And then for how we calculated it, the numeric source, here we have multiple choices. And as we said, we want to use population, the total population divide by the area of each of the feature. So here we would choose to use double field for our calculation. And so then it's we need to choose the first field we're going to use. That one is the total population, and the operator is to divide it, and divide it by what? By the area of each feature. So here we'll scroll down to the field called area, and that's all we need to set. First, choose the the field to be updated. And then here for the numeric for the numeric source, we will choose double field, and then the first operation field is total population, and divide it by the area field, and then click apply. Now immediately we can see the result. Then if that's exactly what you want, just click close. And so here, let's go back to slides and have a quick review on how we can add fields to the attribute of our data set and set the types and names. And then we will use tools under the attributes tab in the edit field, in the edit group, choose use calculate geometry attributes to calculate area, and then use update field to calculate update field to calculate our population density. And here are some hints for the settings for each of these tools. And so now, finally, we need to know the percentage of low-income household in planning area. Now we only have population data in each of the subzone, and so our first step is to summarize subzone population by the planning area, so that we can know the total population and population live in HDB house for each of this planning area. Then the submission field, then the summary field should be a table, and so we need to append this summary result to the planning area data set, just similar to what we have done to append population data to subzone data set. And then finally, as we have those population data for each planning area, we can calculate the percentage of HDB population for each of those planning area. And so now, first, we will have a quick introduction on the tools we are going to use for data summary, that is summary field. So when we use that, it can summarize statistics. It can summarize statistics for our data set, for our original data set by different categories. And then it will save the result to a new table data set. And we can specify multiple fields to be summarized. And so now let's go back to our software and see exactly how can we use this tool. First, before we use the tool, we can further have a look on the attribute table of subzones. And here we can find we have the name for subzones and the planning area it belongs to. And so we can see the planning area is made up by our subzones. As here for the record 8 to 11, you can see there are different subzones, but all of them belongs to one same planning area. So by doing summary, actually that is to say, we can add the data for each of those subzones with of the same records in planning area, and so that we can know the total number of population for this Queenstown planning area, and that's similar to all the records in this attribute field. So to do that, we need to first find the tool we are going to use. It's also under attributes tab, and then And here we need to find a group called statistic analysis. And here you can't choose one record for it. And if I only choose one record in this attribute table and click statistic analysis, you can see that this summary field is inactive. So here we can choose all the records here or just one field here, and then go to statistical analysis again. And here you can see this summary field is active now, and we can click on it. So here, group by means how we want to summarize, the criteria we are going to use to summarize this attribute table. So here we want to summarize all the records by its planning area name. So we can simply click on this one. If we want to use multiple criteria, we can click on more fields as well. But here we will only use planning area name. And then here, as we said before, the result will be saved as a new table data set here, and we will use the default name. And then it's about how we want to which fields we want to summarize. We don't need to summarize all of them. Here we only need to summarize the total population and the population lived in HDB. And first, click on these two fields, and then we can see that there is a setting for statistics type, and we have multiple choices for those. We can summarize them by the maximum records, maximum value, minimum value, or average, or sum, or standard deviation. Here we will only summarize it by sum. Click on sum and uncheck all the others. And also it's the same for HDB. Remember, here we need to summarize them by sum. And then that's all the settings for this tool. Just click OK. And now we will have a result. Double click on it. Here we can see here we can see that in this MP subload statistics table, here under it we can see the record count. We have 55 records in total, which is also the total number for planning area for the country. That is to say, we have successfully summarized them by summarize those subzones by planning area names and get the record for 55 of them. And then we can see here the statistic count means how many subzones each of these planning area has. We can see that some of them are made up by 12 subzones. There are some of them just has one subzones, and also there are some have 5 subzones as well. And here the last 2 fields are the most important to us. The total population lived in HDB house and the total population for the whole planning area, for each of the planning area. And use them, we can calculate the percentage of low income household for each of the planning area. And then to do so, first we need to append this table, especially its records for HDB population and total population, to here the attribute table of MP planning area. We can browse the attribute for this vector file, for this vector data set. Here we can see now it also has a field for its planning area name, but now it doesn't have the records for population. So we will append those records to this attribute table by using the connection field here between them. Here, now the connection field we're going to use are the planning area names here between them. So now let's go to here, go to Data tab, and also click on Append Columns. And here our target data set should be MP planning area, and the connection field, its name should it should be planning area name. And then for our source data set, here we will choose it to be here, this table, MP subzone statistics. And the connection field here is also the planning area name. And then for the fields we want to add to our target data set. Here we only need to choose the sum of HDB population and the sum of total population. And that's all the settings for this tool. And it's the last step in our part. It's not the last step. If you have all the settings down, just click Run and close the data set first. And now, let's reopen the attribute table for MP planning area. Here we can see it has a records for the sum of HDB population and the sum of total population. Our next step is to create a new field for the percentage of HDB population for each of the planning area. Select this data set and right click on it, choose properties, and here go to the attributes tab. As we just did before, click on this add button, and here we need to set its name. And so I will set it to the short for percentage of HDB and click enter. And now remember to click apply. And here you can see we have this new field added to its attribute table. And then select this one. You can still go to edit and find update field. But also you can select this one and then right click. Here we can see under it, we also have an option for update field. It's the same tool, just from different entrance. So here we will calculate the result based on two fields. So here we will set it to double field, and the first field should be the sum of HDB population divided by the second field, the sum of total population. That's all the settings. Then click apply. Now here we can see immediately we have the results here. And also, if you missed anything, you can still go back to our slides and see the hint on all we did before, and all the settings for append columns and calculate the percentage of HDB household. And here also I will have explanation on why we will use HDB as the indicator for low-income household. So here we can see first, you need to know what exactly is HDB household. That represents HDB population represents those living apartments or fields provided by Singapore government with affordable price much lower than their market price. And so from this income quartile distribution chart by dwindling type, we can see that here the dark orange and the light orange column and the light orange categories here are those living HDB flats with less than or equal to 3 rooms, and most of them fall into the lower quartiles here. So in other words, this chart shows that the income of most HDB household is less than the median income of all Singapore household. So the percentage of HDB household here could be used as an estimation for the percentage of low-income household in each of the planning area when we don't have more detailed income data for this case. If you have other income data for Singapore, then you can use those data to find out planning areas with less planning areas with lower income, with high percentage of lower income population. And so this is end for the second part. And now we will have a 5-minute break, and I will review if you have any questions raised in the chatting box. And after that, we will learn about the analysis, flow work, and tools we are going to use for spatial analysis of vector data. Okay, now after the operations on attribute field and field calculation, now we already have all the necessary information we need for the case. So in this third part, we will use spatial analysis tools to find out suitable locations that meets all the criteria we designed for our new Hawker centuries. And so here, first, we have clarified all these goals with clear criteria. So first, for the planning area with high percentage of low-income household here, so we would consider those planning areas of a percentage of HDB population more than 80% as those with high percentage of low-income household. And then for the subnode, of population with high population density, as the average population density for Singapore, this whole country, is around 8,000 people per square kilometers. So here we would consider those subnodes with population density higher than 18,000 people per square kilometers as those of high population density. And then for the proper type of land use, so here we think our new Hawker centuries can build down 4 types of land: commercial and residential, reserved site, and finally white. And then about the proximity to our metro stations and supermarkets. So we would prefer area within 800 meters to our metro stations, and also within 500 meters to our supermarkets. And then finally, for the distance to current Hawker centuries, that should be more than 1,000 meters. And so now we will use a lot of spatial analysis tools to find out areas that meet these criteria one by one, and finally combine them together to get our final result for this case. So here is the workflow. So we can see that on the upper part of it, so for the first 3 criteria, we would use score query to first find out the planning area with high percentage of low-income household, and then we would want to identify subzones in these planning areas with really high population density, and the tools we're going to use is spatial query. And then the result of this step is called potential zones. And then finally, in those potential zones, we want to find out the land of our 4 proper use types. The tool we're going to use is still spatial analysis. So that is to say, for the first 3 criteria, first we will conduct score query once, and then we will conduct spatial query twice to get the result. And then for the last 2 criteria, for the proximity and distance criteria, first we will use buffer zone tool to extract areas meets each of those criteria one by one, like the regions within 800 meters to metro stations, and then regions within 500 meters to supermarkets, and finally regions within 1,000 kilometers to hawker centers. And then we will use overlay to combine these 3 buffer zones together, and the result should be the regions meet all the criteria for proximity and distance. And finally, so now we have 2 data sets. Here, the one on the right represents all the lands of proper type of use in our potential zone, and the other one here under and the other one below represents all the areas that meets these 3 proximity and distance criteria. So our final result should be proper land pieces completely falling into these regions, completely fall into these regions. And so we will combine this data set together again, and then get our final result. And so here I will lead you to complete this workflow step by step. And first, I will introduce you the score query tool. That is a tool enables us to select features based on their attribute tables, and it's under the tab called Spatial Analysis in the group for score query, and we would use the first one. So here, let's go back to our software and then close the table. And to do our spatial analysis, first, we would want to add all the data sets we would use into the map window, so that we can have a clear mind about what we are doing. So here, in the workspace manager, first select MP planning area, and then press Control button in the keyboard and select hawker centers and supermarkets, and also rail station. And MP subzone, these 5 data sets, and then right click and add them to new map. And also, we would want to add land use data set into this map window as well. But land use data set, that is a very, very large data set. And if you directly add it to this map window, it might take a long time to loading all the data into it. So here first, I would recommend you to zoom in to relatively smaller, to a larger, to make this map window at a larger scale. And then select land use and drag it into this window. And here is a warning: this data set is too large. Maybe we need to create a spatial index for it. And so click yes. And now we can see this data is quite detailed. So here, just to have a quick glance at it, and then under the layer manager, you can make it invisible so that you can have a quicker speed when browsing around this map window. And then we can adjust the orders in map window, the layer orders for this map window if you wish. So, and here. Okay, now we will going to use scroll query to extract, to select planning areas with high population, with high percentage of lower income population. So here we will go into spatial analysis tab, and then here on the very left, we can find scroll query and click scroll query. And here, first, we need to select the data set for our query. And so here, first, here, select plan MP planning area. And then on the right, we can set what we want to get in our query result and our criteria for this query. So here I will first clear all my settings before, and so I will lead you to complete them one by one. So here, for the select part, this part means, so here this input means what fields in planning area you want to see in your query result, because we can see here we have a lot of fields here, but we are not interested in all of them. So we can specify which of those which of those are we interested in, and just add and just see them in our query result. So here, like we want to see the planning area name in our result. And so first, click on select, click on the select window, and then move your mouse back to fields and double click on planning area name. So it automatically ended these fields And then maybe also we want to say it's sum of HDB population. So select it and double click. And then also sum of total population, also in the fields, double click on it. And finally, the percentage of HDB household, still double click on it. So that we have added 4 fields into our query result. So we will only see these 4 fields in our query result. And then here, the where window is where we can add the query expression about our query criteria. So here we would want the features we want to select is a feature with percentage of HDB higher than 80%, aka 0.8. So here, first we need to specify the querying field. So still click on where window and then go back to fields, double click on HDB, double click on the percentage of HDB. So that is a field. And then we can enter our criteria. You can enter it by directly import it from your keyboard, or you can add operators from the top. Here, for instance, we can use the operators here to select the values larger than, and then input 0.8. So that's the expression we will use for this query, for this score query. And then we can specify how we want to show our results. We will browse its attributes, and also here check highlight in map, so we can directly see what features we have selected in the map. And then that's all we need to set. Click query. And here directly, you can see that here are features highlighted with those blue outlines here in our map window, and also in the tables under it. We can see that here are only 4 fields as we just specified, and there are 18 records. That means there are 18 which means there are 18 planning areas. That means our expression of the score query. And now keep it as it is now. Keep the selection in this map window, and then we will go back to our slides, and and here you can review all the settings for score query. And then I will give you a quick introduction on the next tool we are going to learn. That is spatial query. Different from score query, spatial query is a tool enables us to select features based on their spatial relationship to specific features in another data set. Like here in this example, we can see that on the left, we have several roads in this map, and also multiple buildings here. And now we have selected one road in the center, and this one. And we want to find out which are the buildings that is within 30 meters to this road in the center. And so to do that, we can specify those criteria using spatial query, and then we will get a result like in this picture on the right. So here you can see that we have selected several buildings here as highlighted with blue outline. And those are the buildings that is within 30 meters to the road in the center. And so that's what spatial query do. That's what spatial query does. And when we're using this kind of tool, here are eight spatial relationships we can use for query. And here's a list of it, and here's a list of them. And you can find this tool under Spatial Analysis tab in the query group. Here is directly, you can see the tool called Spatial Query. And so here is a more detailed introduction on how to use this tool. So first, as we said, we need to select the searching object. So all our spatial query would be based on the searching object or features we selected, like the road in the center of the map. And we have to select it in the map window. And then we can open the the interface of spatial query tool and specify the searching layer. Searching layer means where the features or objects we want to query are located. And then we can specify the spatial query conditions and attribute query conditions we want to use And that is to say, not only can we conduct our query based on the spatial relationships between features, but also we can add score expressions like what we did in score query, so that we can add more criteria for our searching. And then also, if you want to find if we want to find out features within certain distance to our searching object, then we can specify a searching distance. But that is an option. In this case, we won't use this function. We won't use this setting. And so here, now let's go back to our software. And so as we said before, just keep the select result of our score query here in the map window. So these 18 planning areas we just selected would be our searching features for our spatial query. And then let's go to spatial analysis tab and find the tool spatial query. And so here on the top, you can see that our searching area is MP planning area, as we have selected features in this area already. And then we can specify we can specify the layers for our searching. Here you can see we can select multiple layers for searching if you want, but here we will only search in subload layers. MP subload, click on it, and then so that our searching result for spatial query would be features in this subload data set. And then we need to specify the spatial query condition we're going to use. And here, double click on it. We would want to query in the subloads content intersect with those selected planning areas. And then, as we said before, and then if we keep our settings like this, then all the subloads falling in those planning areas would be selected as a result. But that's not what we want. Not only do we want those subloads falling in those planning areas, but we are specifically interested in the subloads, with high population density. So we can further specify our query condition or standards by here setting the attribute query condition. So here, first click on it for once, and then we can click the button on the right. So here in the query expression interface, we can add our query expression for the attribute query. So here we can see. So here on the top left, we can see is the list of fields for data in subloads. And here we want to find out subloads with high population density. So here we will double click on population density field, and it would be ended into here on the bottom right is where we can write down our score query expression. And so here we want to search, and here the expression should be those features with population density that is higher than 18,000. So that's the expression for our score query for our attribute query condition. And then click OK here. It is ended to attribute query condition now. And then here on the bottom left, we can click save our results so that later on we can check if our searching result is right or not. And here we can specify a name for it, and we will name it as potential subzone. And we would also browse the query result in our attribute table and highlight them in the map. Then click query. And here we can see all our query results here are highlighted in this map, and then we can here is still here, and on the right, that is still the result for our plan for our query on the planning area. Close that first, and then we can see this one is our query result for the potential subzones. And scroll down, we have 84 result here, and that's what we need. Just still, as before, keep the selection result here in your map window and close this attribute table. And then another step is, and then so for our third criteria our third criteria is about the land use, and we can still extract our interested. So here we can still extract land, meet those land pieces that satisfies those searching criteria using the same tool, spatial query. So here, going back to spatial analysis again and click on spatial query. And here, our search layer has changed to the subzone data, the subzone layer with 84 objects selected. And then our searching area, and then our target layer should be the land use layer. And then for the spatial query condition, we would want to select land use pieces that completely falling into our subzone. So here we will use contain region between region and region. And then we also need to specify the attribute query conditions, because as we said before, we would only want to build our new Hawker Centris on four types of land use. And so here, set it. First, we need to find out the fields for our land use type. So here, that should be land use description. Double click on this one. And then here on the left, we have a button called Get Unique Values. If we click on it, under it, we can see those are all the unique values for the field of land use descriptions. And we can from those values, we can select the four values we want to use. And to do so, first, we need to go back to write our query expression. And here, so we would write it according to the grammar of score query. So here we will write in capital character, and then we would want to include four types of land use. We can directly select them from the window on the left. And here the first one should be commercial, select commercial and double click on it, we can see that I double click, it is successfully ended to the window on the right. And then the next type of use, the next type of land use should be commercial and residential. And there should be a comma between them. And then add a comma behind. The next one should be, just scroll down. Here, reserve site, double click on this one and add a comma behind it. And then finally is the one called white, double click on it, and then complete this expression. Here, you can just add your own expression here. And if everything is right, let me see if you have questions. Okay, now then click OK. And also save the result. And here we will save the result as land use criteria. And here for the result, as we have already saved it as an independent data set, we can uncheck browse it in a attribute table or highlight in map and click query. Now in the under the workspace manager, we can see we have a new data set and we can drag and add it to our map. So we can see that this one is, so we can see that this data set is all the potential, all the land pieces of proper type of use falling into our potential subzones. And so that's all we need to do to select, to find out all the lands that meets the first three criteria in this case. And then and then we can move back to our slides. So here you can still have a review on all the settings of our query. And then it's time for us to learn another spatial analysis tool that is called buffer zone. Here, buffer zone is the area we created around a feature or around a feature to measure to be measured in the units of distance or time, so that we can identify the areas that would be affected by those features based on distance or time. And so here, for instance, we all know that airports would make some noise. So if we have a new airport that is under construction, and then we can estimate its noise. We can estimate the noise influence it might create to the surrounding areas. That is similar to those multiple buffers, point buffer here as the illustration. And also, if we have some factories built around the river or forest, we can also measure their potential influence, the potential influence of the pollution caused by those factories to our to the rivers or forests. And here we can see that the buffer zone we can create it are two types. There are two types of buffer zone we can create it. The first one is the single buffer zone. That is to say, we would only measure the buffer zones using one unified distance. And then for the multiple buffer, we can specify a series of distance and measure them around our features so that we can see the influence of the features gradually changed according to the distance. And that is a little more complicated, but for our case here, we would only use single buffer to extract areas that meets our proximity and distance criteria. And so here is where you can find the tool. It's also under Spatial Analysis tab. And here under the Vector Analysis group, you can find the button for buffer zone. And here, buffer zone means to create buffer zone. Here, the buffer zone means to create single buffer zone. And if you choose multiple buffer, then you need to specify a series of distance and to create that kind of buffer zone. And if you have 3D data set, then you can also create then you can also use 3D buffer analysis, but we won't have a touch on it in this webinar. And then let's go back here to our software and conduct our buffer zone analysis. Here under Spatial Analysis, we can easily find buffer zone. And then the tool we're going to use is buffer zone. And as the data the features we're interested in are either in point and region, so we can keep the default selection on the data type. If you want to create buffer for line features, here you need to first switch to line features and specify the correct data and specify the data set and set its parameters. The parameters for line features in the buffer analysis is a little more complicated because you can specify different differences. You can specify different differences on the right and left side, on the left and right side of the line. But for our point and region, you can only set one distance line here. And so here, first we will create buffer for our buffer for our metro stations. Here, choose Rail Station, which actually is our metro stations in Singapore. And then on the right, we can specify the buffer radius, which in other words is our buffer distance. And the unit should be meters. And the length should be 800 meters. And then here, we would like to unify the buffers so that all the buffer zones created would be recognized as a large unified feature. If you are interested in the influence of each of the features, then you can uncheck it, and the result we get is independent features one by one, stored in one data set. And here we won't display it on the map. And for the result data set, give it a name. We would call it buffer station. And then click OK. And now here on our data source, we can see the result of buffer station. Double click on it. And that's the buffer zone for our metro stations. And then we can create those buffer zones for our supermarkets and current hawker centers as well. So also go back to spatial analysis and find buffer zone. And here we would specify our source data set as supermarkets. And here the distance should be 500 meters. And also we want it to be a unified result, and we don't need to show it in the map. And give it a name as buffer supermarket. And click OK. Now we can double click on it. And that's all the buffer zones for supermarket. If we switch our mouse to select model and select, we can see that this is a unified feature. If we didn't check unified buffer in the parameter settings, then we will get those circles one by one, and they would be independent features. And now finally, to create the buffer zone for our current hawker centers, and that should be 1,000 meters for the buffer radius. And still click on union buffer and give it a name, buffer century, and click OK. And so our next step is to combine these three data sets together based on our criteria, so that we can get the region meets all the proximity and distance criteria. And to do so, first we need to know which tools we're going to use. And so here, the tools this is the last tool we're going to use, that is called overlay. And so here is an illustration on all the operations we could conduct using overlay tool, and it involves a source data set or source feature, and an overlay data set or an overlay feature. And both the shape and attributes of the features can be changed or updated after we conduct overlay operations. And here, clip, union, erase, and intersect are the four most commonly used operations in overlay. So here, the result of clip and intersect looks very similar, but actually there is a difference between them. So if we use intersect, we can update both the attribute field, both the shape and attribute field of this intersected area at the same time. While if we use clip, we can only extract the shape where the two features intersected, but we cannot update the attribute table of our result. And then for union, it would combine our features together as long as there is an intersection between them. And erase, on the contrary, will only keep the part of the features that are not intersected with the overlay data set or overlay features. And so actually, these operations is quite similar to our mathematical operations. For instance, if we apply overlay to dataset A, which is our source dataset, and dataset B, which is our overlay dataset, and then the intersect result of the equals to both A and B, and erase here equals to A minus B, and the union here equals to either A and either B, and the XOR here equals to either A or either B, but exclude where they intersected with each other. And so here we would use this tool to find out where the buffer of supermarkets and the buffer of our where the buffer of metro station intersected with each other. And then in the intersect result, we would exclude those areas that is too close to our current Hawker centuries. And so here we can find this result. Also, we can find this tool also under Spatial Analysis tab. And so now let's go to our software, and here find our overlay tool. We can see that here on the left, we can simply select which operations we want to conduct to our data set. And here, first we will select intersect operation, and our source data set. Here we should select buffer station, and then the overlay data, we should select buffer station. Make sure you have selected, and then we should select our overlay data as well, and that should be our buffer supermarket. And for the result data set, we would use the default name for it as result intersect. And then simply click OK. If we want to update the attribute table of our result data set, here we can click field settings as well. But here, as we don't need to do that, we can just ignore it and click OK. And now here we can see this is result intersected. Just double click on it. So we can see this result represented areas that is both within 500 meters to our supermarkets and 800 meters to our to the metro stations. So that's a combination of both transportation convenience and life convenience. And then we would want to exclude areas that is too close to current Hawker centuries in the result intersect area. So here we would still use overlay, but this time the operation won't be intersect. The operation should be erased, and our source data set is the result intersect here, and the overlay data set should be the buffer for our current Hawker century, whose name is buffer century, and we would still use the default name for the result data set, and then click OK. And now here we can see a lot of areas has been erased from the original intersected result. Here, as you can see, so here this erased result is are the areas that meet both the proximity and distance criteria of our goals. And also in the slides, you can have a review of the settings. And then our last step is to find out all the proper is to find out all the proper all the land of proper type of use falling into that regions meets all the distance and proximity criteria. So that would be our final result of areas meets all the 5 criteria here. And so to do that, the result the tools we're going to use is still spatial query. And so here, let's go back to our software. And here we have already ended our erase result to this map window. And then we would end the data set called land use criteria, which are the areas that meets the first 3 criteria into the same map window. And then go to spatial analysis. And first unsee it, because to conduct spatial analysis, we need to first select the data. We need to first select the features. We need to first select our searching features. That is to say, we will conduct spatial query based on the result of the based on erase result. So first select it, and make land use criteria visible. And then here open spatial query. And we can see now our search layer is result erase, and we have select the object of it. And then we will conduct our query in the land use criteria layer. And here we only need to specify our spatial query condition. And here the relationship should be contained. And as well, we will set our result. And the name should be suitable land. And here we won't browse its attribute table. We can just highlight it in this map and click query. And now we can see the query result here. And we have saved it as a data set. So here we can go back to the window of our whole study area and add our final result, suitable land, into this map. And for those other layers, we can make them invisible and only keep the one for the layer for our planning area. And also if these 2 layers use very similar color, you can double click on suitable land, and then you can simply change the color of it. And later in our session, in our 5th session, we will have an introduction on how to set those layer visualization and create beautiful map. And so now this is just a simple illustration on our case result. So here we can see this is a very detailed result on which land should we can use to build our new Hawker centuries. And that's all for today. So here is the quiz for this week. And also there's one thing you need to keep in mind, because next week is a holiday for the international worker, for the International Labor's Day. So we won't have sessions in next week. Our next session will be on May 11th. So actually, you will have 2 weeks to complete this quiz. Okay, good day, everyone. If you don't have any questions, have a good day.